So for this video, I'm going to show you how to do a problem using the Poisson distribution and how to do type 1 and type 2 error. So this problem, we've got a group of students getting together to study, and the number of questions they solve each hour can be modeled using a Poisson distribution, so that's given. And one of the students claims the average number of questions the group can solve per hour is 10. And another student disagrees and thinks it's less than 10. So right there, that's where our null and alternative hypothesis come from. The average is equal to 10 is the null hypothesis. We're going to assume that that's true. And the alternative is coming from this Rodrigo, who thinks it's less than 10. But Rodrigo decides to set up the following test. This is where our type 1 and type 2 error come from. He'll record the number of questions the group solves for 1 hour, and if it's less than 8, he's going to reject Sophia's claim. So part A says find the probability of a type 1 error, which is when you reject the null hypothesis, but it's true. So we have to find situations where we're going to reject the null hypothesis, and that would be when x is less than 8. Because Rodrigo's test says if it's going to be less than 8, he's going to reject Sophia's claim. So we have to find all situations where we reject the null. So we have to find the probability that x is less than 8, which is the same as the probability that x is less than or equal to 7. But we're given that the null hypothesis is true. So we have to put in the average being 10 into our Poisson CDF. So 10 goes first and then 7 because of the probability. So I'll show you how to do that on this calculator. It's different, but it's basically the same buttons. You just go to second distributions, and I click the up button to go all the way down. And we want Poisson CDF because it's an inequality. We're finding the probability that x is less than or equal to 7. So I type in 10 and 7. Yours would say mu, and so you type in 10 for mu, and then x value would be 7. And then you say paste, and it pastes to your home screen, and you should get this probability. So then for probability of a type 2 error, it tells us the average number of questions was actually 8.4. So that's actually the true mean. And a type 2 error is when you accept the null, but it's false. So if the actual average is 8.4, the null hypothesis is false. So we have to find all situations where we would have accepted the null hypothesis, but it's actually false. So in order for us to accept the null, we would have chosen values when x was 10 or more. So we have to find the probability of x being 10 or more, which is the same thing as 1 minus the probability of x is less than 9, because our calculator cannot do values above 10. If I type in 10 into my calculator, it's going to do 10, 9, 8, 7, all the way down to 0. But I want the opposite of that. So 1 minus the probability of x is less than or equal to 9. But we're given that the null hypothesis is false. It's 8.4. So that's what we have to type into our average value for the Poisson CDF, and then we type in 9 because of the probability that we're finding. So, and then we just do 1 minus that. And here's how you do it on the calculator. You can go ahead and type in 1 minus, and then second distributions, go to Poisson CDF. And now we want to type in 8.4 for the mu value, or the average, and then 9 for the x value. And there you go.